Today we'll talk about alkene oxidative cleavage, two ways to do it, ozone, or using hot potassium permanganate. So for ozone, you just replace alkene with a double bonded O, and for hot potassium permanganate, you would follow this rule. Keep in mind it has to be hot potassium permanganate. If it were cold and dilute, it would be another reaction, making a vicinodiol. Okay, let's try our first problem. We're given the product, what could have been the reactant. And I represent this in many different ways. The idea is that anytime there's an O, we're just going to replace it with something on the other side. So I'm going to just redraw it. And now instead of an O, I'm going to replace it with a C here. And on this side, same thing. Instead of an O, I'm going to replace it with a C. So we don't have to draw a C. So it's going to look like this, our product, which, as you can tell, is a little bit longer. It has 5 carbons now. Yes. So for question 108, we're putting this through ozonlysis again, and we are going to just break this ring apart, and wherever the alkene was, replace it with an O. So to draw it a little bit nicer, it will look something like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There is a terminal O, and this side is an H. Boom. Okay, now let's talk about the potassium permanganate ones. So for 103, we're given the reactant, what could be the product. But this time, instead of replacing alkene with a double bonded O, you actually have to count the fact that this corner, it is monosubstituted. So that means you are going to add an OH as well. So it's going to be a carboxylic acid here. But then for this alkene side, it's disubstituted. So this will be a ketone. Boom. And a nicer way to draw it would be something like this. 1, 2, 1, 2, perfect. Okay, for our last problem, once again, hot potassium permanganate, and we're given the product. We have 2 of these. What could be the reactants? And we can tell that this is actually going to be a monosubstituted alkene. So we're going to have one thing on this side, one thing on that side, and the fact that there are 3 carbons means we are going to add 1 carbon here, 2 carbon here, 3 carbon here, 1 carbon, 2 carbon, 3 carbon, giving us a solution 3-hexyne. And I hope this video was helpful. If it was, make sure to drop a like.